Right, week 10, video 6, Thinking OO. So in the previous videos so far, for this week's videos, I've been introducing step by step how we can use Python to write our own classes. So we've introduced the simple stuff for a start, and we've got more and more difficult examples until we got to the point of adding arithmetic capabilities to our color class. So the question now is, given that you also know how to write classes, how does this alter your programming? How do you use these things in your coding? And this is a moderately challenging and difficult issue. So we're into the idea of object-oriented programming. And in object-oriented programming, pretty much everything is broken down into classes. So you're used to the idea that you break things down into functions, possibly then into modules. But if you're programming in a language like Java or C#, you're actually having to write classes right from the start. You can't write any code at all except code that's in a class. This changes the way in which you think. But it changes the way in which you think over quite a long period of time. The first time I encountered object-oriented programming, I programmed solidly for 3 months. And at the end of that, I thought, wow, I'm really getting the hang of this. And I showed my code to a colleague who said, oh, this is terrible. You know, why have you got such big classes? This should be a separate class. This should be a separate class. Break it all down more and more. The same thing probably happens to you when you program in functions. I come along and say, no, there's too big a function, break that down into smaller ones, and so on. It all comes down to familiarity with the construct. So because it takes months to acquire this different way of thinking, we don't expect you to master it in the space of a 1 week 1-to-1 course, 1 week of our 1-to-1 course. But I would like to introduce the ideas to you so that you can start to mull them over the next few months and even years as you conceivably move into a career in software engineering. So the way in which things change is that up until now you've been thinking about what we call procedural actions. I do this, I do this, I do this, and so on. And you break the procedural bits into functions. So a function captures a small chunk of the whole program, the procedure you carry out to do something, a sort of recipe, if you like. Object-oriented programming is a little bit different. You start instead to think about the data you're dealing with. We talked about color, and we showed how color is made up of red, green, and blue, and we talked about what you could possibly do in the way of manipulations on color objects. So that underlies this whole idea of object-oriented programming. What classes of data do we have? What are the attributes of each class or the object in each class? And what operations, what methods do we need for those objects, those classes? It also often helps to think in terms of objects in your program as being somehow alive. So when you look down here and you see str of color, how does it know, that word know, how does the str function know how to convert a color into a string? And the answer is it asks the color object how to do it by calling the object's str method. So the idea of calling and asking color.done.str is asking the object how to convert itself into a string. And so this is another change in mindset, a change in way of thinking. Now, some years back, we had in our department a real OO guru called Warwick Irwin, and he left to work in Google actually, and he introduced me to this particular slide, which I'll put up and won't talk about too much, but it's a slide from the Wikipedia of 1986, the Encyclopedia Britannica, the encapsulation of human knowledge at the time, and it argued, you may want to pause the video and read through it, I'm not going to read it to you, essentially it argued that the human brain, the very basis of our thought, is objects and classes. That is, we think in terms of the individual objects in our world, what their attributes are, and how they're broken down into components. So the tree, how big it is, what the trunk is, the branches, the leaves, and so on. And that we make classifications, so that our brain, according to this sort of idea, is a classification engine. And Warwick used that as proof that OO programming is natural and simple and everybody can do it easily. my experience trying to teach OO over many, many years, decades actually, is that this is twaddle. It isn't natural at all. It's very much, it's arguably natural that we pick up the classifications that other people teach us. So we learn to recognize trees and people and stones and rocks and mountains and things from a very early age as people are teaching us vocabulary. But we don't make our own classifications anywhere near as easily, and in particular when we're programming, this isn't easy to make our own classifications. I put it there though just as a matter of interest. What I do expect, even if this is difficult, what I do expect is that you will be able to learn in the space of this course to recognize the idea, sometimes at least, that maybe we have some convenient, what we might call records to write. That is a very, very simple idea of a class. So if, for example, I find myself having function calls, I'm often calling some function with a row and a column, then if these are always passed around together, maybe they belong together. And if they belong together, what's the natural way of packaging them? You may think it's a tuple at this stage, but hopefully when you get a little more familiar with OO, you'll realize the natural way to package them up is in a class of your own. And here's a simple example of that, which we've used a couple of times through the course, which is the idea of a class point. So once I have written my class point like that, once I've run it, then I can talk about P as the point 1020, and I can print the point P and get some sort of printout format like that, and I can pass that into functions. So I can have some function def triangle, which it consists of or takes 3 points, P1, P2 and P3, which are its vertices. And it's much easier to write that than to pass in the point x1, y1, x2, y2, x3, y3. So this simple idea that if things are being passed around together, maybe they belong together, maybe therefore we have a class, is something I do hope you'll get the hang of in this course. And also, one of the other big things that this gives us is the ability to talk about the elements as with a nice convenient syntax like p.x. This is much better than talking about the p0 or the p1 or the p2, where p0 is, for example, well, somebody's name, and p1 is their age, p2 is their address, or maybe it was p2 was the address, p1 was the address, p2 was the age, can't remember. Much easier to give them names. P was person in that case, not point. So there's my person. I should have held off that little explanation till I'd done it, shouldn't I? There's a class person, which I've got here, and you'll see we've just declared a class person. We've given an initializer for it. We haven't even written a str method for it, so we can't print the person as such, but we can print their name. So bod1 is the person Fred Bloggs, 27, and we can talk about their name. I've said much better than a tuple. Why? I hope I just explained that, because bod1 square bracket 0 isn't naturally communicating to the reader that this is the person's name. Another example here is a course, and you may want to type those in and play with them just briefly to add to your general understanding. Moving on. No, I don't have to move on. That's the end of this video. Oh goody. Thanks for watching. Bye.